I'd like to now quickly go through the scheduling algorithm so that you hopefully can get an idea of how this works as I actually work through it. It's going to be a little tricky for me to hold the camera and also do the diagramming, but if you'll be patient with me, maybe it'll help. Maybe this illustration will help. Assuming you can draw this diagram as I have done here, we went through that before with going from the precedence list to the AON diagram and then to the AOA diagram. So again, it's precedence list, AON, and then to the AOA, which this is an AOA diagram, which stands for activity on arrow. And you can see that's called that way because the name of the activity is on the arrow itself, where in the AON diagram, the name of the activity is inside the circle or square, whatever shape you're using. Scheduling is really simple. You have to convince yourself this is easy. Once you get the idea, it's very quick and it's easy to do. And it just takes a minute. It's just arithmetic. It's not any kind of higher math. And we always we draw a square at each node as I've started here. Again, I number these nodes with odd numbers. That's just my habit because later on I may want to come back in here and draw another arrow in here and give it a number 2. So I just do that. I found from practice that sometimes I need to have leave space for adding another activity at a later time. We always, again, the squares stand for early start, and we always start at 0. So we always put a 0 in the first square. That says that's the time now is when we're starting this project. So given that we're starting the project at time now, then when will this project finish? Well, it starts at 0. It takes 5 time units, or 5 days, we're going to say. So therefore, it's going to finish on the 5th day. So these activities following A cannot start until A is finished. So you can see how the precedence takes effect here. So this becomes a 5 here in this square, which simply says that these two activities cannot start until the end of day 5. And going down below here, we noticed notice that B has a day duration of 5 days, and 0 plus 5 is again 5 in this early start or square. It gets a little trickier when we get over to node 7 here. So I draw a square here, as you see, and there are 2 incoming activities to node 7. There's C, and I didn't label this one, which is actually D, and it is a 7-day activity. So we'll have 2 precedences determining when F and G can start, leaving from this node here. So it's going to be determined by the latest of the 2 incoming arrows. Which of these 2 is the latest? So I go with 5 plus 10 is 15. I'll just write that little note there to myself. 15. I wrote a 15 right there. It's hard to see my writing, but I wrote a 15 right there. And then 5 plus 7 is 12. So the number we're going to take is the largest number. So that's the latest of the incoming activities. So these activities leaving this node cannot start until the latest of the precedences are finished. So we take the maximum. So when there's a choice, just think of this rule yourself. When there's a choice, as there is here, I can tell because there's 2 arrowheads, I'll take the largest of those 2. In this case, it was 15. I have the same situation up here at node 9. Again, I draw a square. This is for the early start. And I look at the previous. I have 5 plus 6 is 11. I wrote an 11 over here as one of my choices because I'm going to have 2 choices. And then it's going to be 15 plus 11 is going to be 26. So that's the choices. And obviously I'm going to take the 26 because it's the largest of those 2 numbers. And then down here at node 11, there's no choice. I just do a simple addition, and it's 15 plus 6 is 21. And then coming over to the end of the diagram over here, and I'm going to have 2 choices again because I have 2 arrowheads coming in, so I know I have two choices. So it's going to be 26 plus 11, 26 plus 5 is 31. I'll write that down. Or 21 plus 4 is 25. I'm going to take the maximum. So that's going to be 31 days. So I've just determined what the project duration of this project is. It's going to be 31 working days. Now I want to find the critical path, which requires me to take a backward pass. So I need to draw a triangle from at each node, which is going to be the late start time, and arbitrarily I just put that number right back in there. So I put 31 in there, which means I want anything following this activity to start no later than day 31. So this means everything must finish by day 31. So I'm forcing it to finish on 31's day. So if that's true, how late can activity I start and still be on time at 31? So I subtract 31 minus 4, and I will get a 27 here. 27. 31 minus 4 is 27. So you can see there's a difference here. There's a difference between the early start and the late start, which means a good news possibly for the project manager, because that means there's some slack or float in there, which means I have a few days that I could delay that activity if I needed to and still finish the project on time. Going back this way from node 13 back to node 9, I have to, again, by subtraction, draw the triangle in there. And by subtraction, I have 31 minus 5 is going to be 26. And there's only one choice because there's only one tail of an arrow going in there. So 26. This is 26 and 26, which indicates that this activity H cannot be delayed because the early start and late start are the same. Then I come back to node 7, and there are two tails of arrows, which means there's two ways that these activities go forth out of this node. So I'm going to be back. I'm going to have a triangle at this node. Sorry, my graphics aren't real neat. And I'm going to have 26 minus 11 is 15. That's a choice. I wrote it over here. 26 minus 11 is 15. Or take the late start now, which is 27 minus 6 is 21. And now I take the smallest. When I'm on the backward pass, I take the smallest number, 15. And then going back up here, again I have two choices at this node. So I have 26 minus 6. Over here is 26 minus 6 is 20. Or, coming up this way, 15 minus 10 is 5. So 5 is going to be the smallest number of those two. Again, the backward pass, you're taking the smallest. And then finally, here we have two choices at the first node, which is going to be 5 minus 5 is 0. I put a 0 there as one of my choices. Or 5 minus 5 is... I didn't fill in this triangle. That's what makes me up here. I have to start here. 15 minus 7 is 8. So this one I didn't fill in. I have to do that. So my choices are 5 minus 5 is 0, or 8 minus 5 is 3. Take the smallest, or 0. Now this always must be the case. You must come out with a 0, 0 at each end. Now to finish up, I want to find the critical path, and in that case, the square must equal the triangle at each end, and the difference must be equal to the duration time. So this is 5 and 5 at this end. This is 0 and 0. The difference is 5, so that's a critical activity. This activity here looks critical. It's 5 and 5, 26 and 26, but when I subtract 26 minus 5, I don't get 6. This is not critical. This one, on the other hand, this one is critical because it's going to be 15 minus 10 is 5, and that is critical, so I draw that in. And similarly, I will find out that the critical path goes this way and this way. So I found the critical path by those three rules.